You're listening to All Things 3D, where we talk about the world of fabricating, designing, and capturing in the third dimension.
Hello, hi, this is Mike Balzer, and this is a special edition of All Things 3D. I have with me today Dr. And I've already forgotten the name.
Javin's
you're welcome
fine.
to Javin.
Yeah.
Let's see, it's Dr. I'll get it correctly, Shefflin,
Yes.
who is joining me. He's reached out to me after he's found out what I did with the Make article, and we're kind of going to go through a brief tutorial on a product called 3D Slicer, an open source, what do you want to call it? It's scanning software tool to allow you to create tangible models as well as what they call 3D volumes. We're going to go through that, and then we're actually going to go through the entire process of actually to a printer. In fact, I have my little trusty Ultimaker to go here. I don't know if it'll be up for the job. I'm still tuning it, but I'm not going to waste your time with that, but we'll at least get there. I do have a model that I created early right now that we'll be able to pull off of it. So without any further ado, I know that you didn't want to speak a lot about yourself. Now, do you want to be called Javin, Dr. Shefflin? How would you like to go?
Javin would be great.
Okay. Well, great, Javin. Why don't you tell us a little about yourself, why you came into this area? Obviously, we're marrying technology again. What's new? That happens all the time. And but I'd like to know a little bit more of why you're interested in this.
Sure. So my name's Javin. I'm a radiology resident. And part of my interest when it came to 3D things, besides reading the article that you've mentioned already, was it just fascinated me, the idea to take two-dimensional radiology and kind of bring it into the new dimension. And
yeah,
sorry.
Sorry, a little bit of, obviously, if you've been listening to me before, you know my background. I got into this, and I actually did a TED Talk in Spain on July 4th. But essentially what I said is that I was doing one of my week or shows, and I noticed that a Malaysian neurosurgeon had 3D printed a skull and brain and was using that to create practice surgery. So at the time I thought it was novel, and obviously there was some irony there because my wife was diagnosed with a tumor, and I thought, wow, maybe I can do that. So that was my journey, and so I did a lot of exploration, and one of the things I found right away is a lot of these tools are really expensive. So I can imagine somebody who is doing some research in this may not have a large budget. What can they do about it? And then again, that's why you reached out to me. And so I kind of like to bring up right now that tool so that you'll get an idea of where we're going with this. And I have actually had the gentleman, his name is Stephen Piper, and he's kind of the project lead behind this, and it's called 3D Slicer. Currently they're on Slicer 4.4, which I think has a date of like November of 2014. But if you click on the download, you'll find out that they have several nightly builds, and this is the one that we're going to be working with today. Sometimes the nightly builds, as if you're familiar with it, don't always work properly. So always have the stable release on your machine before exploring one of the other versions. But let's get right into it. Slice 4 is, let's see if we can get into a more generalized. Here we go. Let's look at the introduction of the application. But again, I'm going to go through it briefly. You can explore all you want if you're listening. There's a lot of good information, a lot of other tutorials out there if you look for them on YouTube. So hopefully with the interaction with Javin, we'll be able to get through this and have a better understanding of it. But what is it? It is a free open source software package for visualization and image analysis, and it works on both Windows, Linux, and Mac OS. So that's a lot to say for a free package. It is there's a lot of contributors throughout the market on this. Other researchers have created, I think it uses Python, so there's a lot of Python scripts that people have put together. It identifies right here some of the highlights of it, and we're going to only explore probably just a few of them. It's got a ton of stuff in there. And that's probably the first thing, is kind of wading through, as I call it, the Swiss Army knife of 3D visualization. Like a lot of open source, you got a lot of excited people making things for it, and it just kind of, some in my case, kind of bloats it. And so you have to kind of wade through some of the features you don't know and get right to the ones that you do need. So you can read this as well as I can. I think this has been around for several years now. Stephen Piper is, in my opinion, a really nice guy, and I think he's doing a great service to the medical and research community with this, and I wish him the best of luck, and one of the reasons I support it. So on that note, let's kind of move to another camera. Actually, before I do that, let me show you some of the models that I actually created using this software. So I'm not just blowing some smoke. Yes, I actually used it. And if you see down in the corner there, you can see my Ultimaker to go with a little skull on it, little tiny skull. I like to tease my wife. That's part of the mini her. In fact, I created a little mini surface model of her that I take everywhere. It's called my mini wife. So I'm kind of big into this. So let me show you the first model. And this is the one that you'll see in the TEDx talk when it finally becomes available. This is the first model that I created. And this was, I think, 3mm slices. And you'll see once we get to the data that Jevin sent me that that particular model we were looking at is 1mm. And the big difference is you'll see some ridging. And the reason for it is because it has a coarser definition than some of the newer CT scans, or how they were adjusted. But inside this, you can see that the tumor that she had, let's see, there we go, right there. And so what I felt the power was, especially for me being a novice, is that I could actually touch and be able to describe the anatomy, kind of look up things on Google and so forth, but have a model in front of me. But I also thought it would be important to send it to our surgeon. And what he told me, it was great for planning, and they could see it because UPMC is also an educational school. The ability to be able to use these for educational purposes, using real live current data instead of historical data. So they see a lot of power in this. In fact, one of the fellows for Dr. Gardner was really excited. Now, we talked about 3mm, which was this one. And now we can look at 1mm. Now this was the CT scan done at UPMC with 1mm resolution. Notice the smoothness. Now it is somewhat translucent, so it's not like you're seeing a ghost there. I did use a translucent material with this one. And this was an after. If you notice, the other one had a tumor. Now she has, as I call it, another hole in her head. As you can tell, we kind of kid around a lot. In fact, this is the one that you may have seen in the Make magazine. Much better definition. However, because I think part of the reason that it had better definition is I think the Roentgens that were used was higher. I also noticed there was some flaring in the teeth. And maybe Jevin can kind of explain that to me a little bit later, why you see that. But so this was another model created. The other cool thing, those were both one-time scale or full scale. Here's a little mini version. I think this is maybe a 1/3 model. And if you notice, this is cut differently. That showed the anterior view. This is the sagittal view. So again, same model, same hole, but now we can look sideways. So we're going to explore how we can actually do that and create models from it. And then if you want the best in quality, you can always go to an SLA resin based, and this is a skull I created, again translucent, and I mounted it on a little, and the battery's dead, a little LED light, and made a cane out of it for I can't think of Day of the Dead here in California that we went to. Again, if you look closely, there is a hole in there, so you know whose skull that is. I have to thank my wife. She's been very patient with me. She obviously has become an icon in this industry, if she wanted to or not, but she did a lot of work there. So do you have any questions for me right now, Jevin, before we continue?
Nope. Everything's good.
Okay. Well, please interrupt me, because then, that's the strength of being able to do Google Hangouts on air, is having people come in. And then if you are out there in the audience and you're watching this, please feel free. And I think I enabled it. I hope I did. Yeah. If not, you can email me. I'll keep that up and running so that you can email me, so that we can kind of go through and see if there are any questions from you as well. Okay. So give me a moment. Okay, so what I'm going to do now is I'm going to jump to the actual screen, which is right behind me now. And this is on my laptop. Now, the strength of this 3D slicer is you can pretty much use it on anything. This is about an $800 15-inch laptop that I'm working. It's an Asus. It does have discrete graphics. One of the strengths of this application, and some of the others that are out there, is that it does use a GPU. So if you have a GPU based computer, you'll actually see some benefits in the model creation, which means you can rotate and things almost in real time, which is a strength. And you'll see that once we move into this, that some of these models are fairly realistic. So the first thing that we want to do is be able to bring something down. So there's a couple of ways of doing that, and we're going to explore two methods today. One, let's go ahead and look at some test models. So the nice thing that they did is provided downloadable sample models. So we're going to download, and the way that you do this is when you click on the data icon up here, you can do that. But I'm getting ahead of myself. Let's kind of look at the original screen that comes up before you make any modifications, and things can be modified. You are greeted with a 3 window, which is your 3 views. And, Javin, I'm going to kind of keep it basic, but essentially your top view, side view, and front view. And then also you have a 3D view here over that you can rotate with your mouse. This is very important because this is where the actual model shows. Now, I may modify this later on because I like to have a bigger 3D window. But again, all of it is flexible, and we'll go through some of that. And then up here is your menu items. You have this here that you can pull down, if you can see that, and it gives you a lot of features. Remember I mentioned Swiss Army knife? Yeah, it's a Swiss Army knife. So the ones that we're going to be looking at is the ability to create volumes, volume renders, and models. And these are the 3 areas, as well as the DICOM area and data area. These are important because, one, you need to have ability to bring in data. So if we click on data, if you click on data up in the left-hand corner, then you can choose a directory to load something in. Now, this is the raw data that the program itself creates, not the DICOM information. If we want to load DICOM, we click on the DICOM. Now, I've already loaded in some data that I was using earlier on myself, and also DOA, which is the information that you had sent to me. Now, with each of these, it also identifies the studies that were created. And for somebody, it tells you the institution's name and who referenced the particular scans. And so you've got some basic information from that. Now, I'll go to mine. If you click on it and you'll notice that each one provides you different information depending on the type of study that was created. And you can see that in the lower quadrant here, or I guess it's not a quadrant, the lower third half of this particular screen. Now, if I click on the DOE at this particular point, there's only one study, but notice the number of scan sequences that were done. And the one that we're going to focus on today is the 1 millimeter planning. What I found is that some of these, they can focus on, again, a 2-dimensional emphasis. So if you want to do a coronal or sagittal emphasis, you would only get that. But for 3D, you kind of need to have, like in this 1 millimeter planning, the same quality for each of the different views. So you'll have to be careful. It's one of the things that it's a little cumbersome with this. You kind of do have to play a little trial and error until you get some experience on which ones actually provide that for you. For instance, I also looked at the bone and the diagnostic, and I found that some had a little more emphasis than other. And what that does is it creates one area that seems very sharp and the other areas are very rough. So try and find the one that has the best balance. And if you have some choice, which more likely you won't, unless you're a researcher like Javin, you can identify to the radiologist, since he is a radiologist, he can order himself for the technician to provide a balanced full-scale scan. And, Javin, you're welcome to jump in at any time if I get something wrong.
No, I'm sorry, Mike.
No, go ahead.
No, one thing I was going to say was this is actually a good example. This scan that you're working with, the 1 millimeter wasn't uploaded originally into PACS, which is pretty much the operating system that most DICOM viewer that most radiologists use. And I went to the techs after they did the scan and I asked them just for the hard data for the 1 millimeter. And, even though it wasn't in the initial PACS file that they gave us, they still usually have it. So just as like a tip to any radiologist thinking of getting started on this, just because the 1 millimeter isn't on the PACS that you just took doesn't mean it wasn't taken. So always talk to the techs and see if they still did send it through, and you can maybe get them to pull it up for you, like what I did here.
That's good. Well, it's interesting, and you sent me 2 data sets. Maybe it was both of them had the 1 millimeter planning, so it must have been something you caught even before I got the first.
Oh, okay. Yeah.
But yes, that's a good point. And another cool thing about the DICOM, because it is essentially mainly grayscale images in either 24-bit or 32-bit, and essentially a database, a lot of metadata that's associated with it. And there are quite two-dimensional DICOM browsers out there that are free. And there's some even online versions now, which I've looked at a couple. I think Image 32, I think, is one of them, that allows you to upload your information and have other medical professionals review it with you. So I think we're heading into the day where snail mail won't be needed anymore. I did ask them if they'll provide 3D functionality. That's in the future. So we're kind of ahead of the game still here.
Yeah,
okay,
and,
so I'm going to...
Oh, Mike, I was just going to say a DICOM viewer that I actually like. It's called Radiant, and it's also free if anyone was.
Okay, well, please make sure you email me that, and I'll put it in the show notes for this episode when we're done.
You got it.
Okay, so let's go back again. Like I said, we want to actually bring in some. Now I won't know how to get back. Download samples. So I actually go up to the file menu and pull it down. So the one that I was working with earlier, is, since we're actually going to be looking at another skull, and I obviously have a lot of experience with skulls, is download the MRI of the brain tumor 1. And it's also another good example. There are actually multiple types of scanners. A positronic, but they all use different types of, what do you want to call it? Not necessarily radiation, but particles. The CT is more of an accelerated electron, just like an X-ray, that's done in slices. And I won't get into a lot of the detail on that. An MRI uses electromagnetic energy, very similar to RF radiation, like is emitted out of your phone. And then positron, I think, is a positive. Isn't that a proton-based device? So the reason why is because they interact differently with the body, and that gives you different reactions. And so you might see, even though that they provide the same kind of grayscale images, they all react differently, so they provide different information. So here we're seeing both MRIs and CTs, and then we also have we call it a DT volume. Does that make any sense to you, Javin?
Yeah, DTI. It's similar to MRI. It's a different imaging modality.
Okay. So there are obviously a number of different types. Ultrasounds also have a DICOM variant, and that's becoming popular because the type of radiation is ultrasonic, so it appears to be safer. We'll see what the long-term efficacy or study is on that. But so that's popular, and it's actually less expensive as well. And we're starting to see that, especially in the fetus market, people wanting to see their baby. In fact, a few weeks or months ago, I actually explored it about a year ago, but I actually was able to take a 30-day GE variant and kind of fool it into believing that I had a server, and was able to actually bring in some ultrasonic information of a fetus, and was able to print it. So it actually was a pretty cool process. But Sadly, GE kind of keeps a lock on that particular ultrasonic 3D information, so it's still not available to anybody outside their own format. All right, well, I'm kind of distracted a little bit, so let me focus back in on what we want to do, and that's bring in. And notice how quickly, and I think it's because I had it loaded already. Most of these aren't complete studies, so they do download very quickly. In this case, this example here, as we said before, we're looking at a top, side, and front view. And just to go through the controls of these particular positions, you can use your scroll wheel to actually go through the slices. Now keep in mind that DICOM information can either be based on a single slice or multiple. And the strength behind CT and MRI is the ability to literally create images based on a three-dimensional location in the body. So as they call it, slices. And they're kind of layered together, one after the other. So the scroll wheel here is pretty powerful because it actually allows you to, and most of them use this, scroll through very quickly the different slices. And as you can see, as we move through, let's say in the top view, if you look at my head kind of going like this, imagine that's what it's doing. If I do this on the side, same thing, but it kind of goes like this. So if you can kind of imagine that occurring, that's essentially what we're doing. So the other buttons that become useful is the ability, if you hold the left mouse button down, to adjust the, not necessarily the threshold, but the grayscale level of the document. If I pull it down, notice that we can actually blow it completely out. If we bring it the other direction, we can go all the way to black. And then what we want to do is create a compromise in between there. Now that's good for viewing this, and later on we're going to see the actual tool that does it because it's very important for us to create tangible models. But for now, we're going to play around with the ability to do, and I'm going to close this window for now so that we have a larger setup. But let's say you're not satisfied with this setup. Let me go into what else we can do. Notice we can do the conventional, which gives us the three views on the bottom, and then a larger three-dimensional view on top. And if you don't like that, you can go to a conventional widescreen, which is kind of fun. That puts them off to the right-hand side, and then the three-dimensional view here. So, you know, again, because it's a Swiss Army knife, they threw everything in there, so you have a lot of control over how you want to look at it. You can also have multiple windows, like you can do a dual 3D, which allows you to use different volume renders in each one of the windows for comparison, visual comparison. And there are actually some tools to do actual volume comparisons as well. Tab 3D, so you could have multiple views up here that you can just click on. So there's a lot of strength, and it's very easy to work with. So I'm going to go back to the conventional widescreen because it'll give me a 3D. And it's the one that I like to use because I find myself not really working as much with the 2D images, but more working in this. So what I want to do right now is create a 3D volume. So that's the first thing I'm going to do. Now, what is a 3D volume? A 3D volume uses the graphical ability of the computer, like I mentioned, the graphics processor unit to Javin earlier, of whatever you're using, either a desktop, or in this case, I'm using a laptop, to produce a, what do you want to call it, a combination of all the slices together. So it's taking that three-dimensional information to create what they call a volume. So seeing is probably a better way to see, to understand this. So I'm going to immediately go into creating one. And you do this by pulling down this little main menu here, clicking on volume. Now the other strength behind this is it actually is also here, if I remember correctly. This is volumes, models. Actually, they don't show it here. I could actually pull that icon over here so it could be on my main menu bar as well. So I'm going to click on this, and then it brings up a little screen. Now you can actually drag all these screens to where you want. Let's say if you had multiple monitors, you can actually pull it on the other monitor. So you can concentrate just on this screen here if you wanted to. So what I want to do, since we haven't loaded that many volumes, we could actually have 4 or 5 volumes loaded up. We need to make sure we select the right one. And right now I only have one. Now I'm going to keep this loaded when we bring in your information, Javin, so that you'll see why it's important to realize it, because if you don't select the right one, you may be making modifications and realize it's not working. So once I do that, one of the things that I need to do is select the input. And I can identify the region of interest, ROI, and a few other properties. So I'm pretty much going to leave all this alone because I don't need to do anything with it. And then I can select a preset. But what I'm going to do before doing any of that is immediately open the eye. Now, if you notice, there's an eye here. Now, let me do one other thing so you can see what people have worked with in the past and what you can use now. First, I'm going to, you see, I'm moving this little icon here, and what this allows me to do is link all the three views together, which is great if you want to do the same thing through each of them. I am going to select this, which will center the, what do you want to call it, the region of interest location right in the middle. And then I'm going to turn on the three views. But these are all still two-dimensional views, like cards placed in their proper three-dimensional space. And you're probably already familiar with this, correct, Javin?
Yeah, a little bit.
But what's cool about this is that it allows you to see how this would look like in three-dimensional space. And you can literally move the slices, as you can see here, wherever you want, and then you can rotate. Another strength, let's see if I have to turn it on here. Well, we'll do it later on. You can do what they call ROIs and look at them in 3 dimensions, and we'll play with that. So the reason I did this is because we're going to immediately turn on. Let me move this out of the way. Oh no, now it's, there we go. Yeah. There we go. Now, let's see if I can make the windows smaller. Yep. So now I'm going to turn this on, and what it should do is fit immediately over these 3 cardboard slices. Voila. Now we have a 3-dimensional model. Now I haven't done anything other than just turn it on. Notice that we're seeing basically the whole external surface of this gentleman. So if you're wondering the potential of using CT scanning for surface scanning, it is amazing if you can afford to use it, but it's being used in Australia to do, what do you want to call it, synthetic cadavers that they're going to be selling. So countries that have laws against it, or just because cadavers can be expensive or hard to find, these models. So they used a lot of CT to create high quality surface scans. The Smithsonian has a CT that they scan. In fact, they just got finished scanning Neil Armstrong's spacesuit, which we covered in the last episode. So it has other things besides just medical. They use them for inspections because it can penetrate and view things internally. So if you're wondering, yes, you could scan yourself and make a model out of it. It would be expensive. There are other alternatives. But we want to do something else. We want to be able to look inside. So one of the things that you want to do is select a preset. And there are several presets that give you immediate, what would you call it, gradations of color, as well as the, what do you call it, the threshold of grayscale that would be used, for instance, for, let's say, a skull. And we'll go ahead and use CT AAA, which I found to, actually, it's not doing that, but I guess I'll have to, let's see if this, okay. Let's go back to, I think the rest of these down here are, oh, actually, we do have an MRI, so excuse me. So let's go to this one. Okay, so it just changed the color. So with a CT, normally the thresholds, which were the first ones, can immediately give you bone. I have to tweak this a little bit. MRI is a little bit more difficult. In fact, one of the things that I identified is if you look at the images off to the right-hand side here, the bone is actually this dark space. Unlike CTs, which seem to illuminate the bone because of the reflection, MRIs just go right through it and is absorbed and shown in the actual soft tissues or tissues where you get all your highlighting. So we would actually have to inverse this. So we're not going to use this for the strength of doing bone. We'll have another one to work with, but we want to look at some of the tissue. So one of the things that we can do is start, if you can see this over in the, my head's in the way. Get out of the way. You can actually modify it. Well, one of the cool things that I like to work with right away is synchronize with the images over here in the volume. So watch what happens. It immediately changes color. And then notice that I have a haze around it. But if I go through and adjust this, notice it changes the colors that you see there. Can you see that, Javin?
Yeah.
Okay. And then we can go over here and start tweaking. I actually have to switch it off now. But now we can go in and start tweaking our threshold levels. And we can delete or create new spots, but it's not cooperating with me. So let me go back up here. There we go. And then start with a pre. But notice if I start moving these around, I can actually vary. See how I'm changing the color? If I do this, see how I just modified it into a big block? But if I go in this direction, there we go. Notice how it's becoming transparent because I've modified the threshold levels. And then I can go in and actually change the colors if I want, so if I don't want that color. So let me go back over here and remove our cardboard items so we can actually see the model. So notice how we've got some transparency because we modified how much we can actually see. And you have to be careful on how you grasp this line, because if you don't grasp one of the pull items, you add another one, and then you'll have to delete them.
Is there any way to reset it back to the kind of standard if you, let's say?
Well, you can always go back to one of these and you can create your own preset. So let's go back to this. Yeah, call me a liar. There we go. And so we can always go back to one of the presets you start with. So see, notice I just grabbed the wrong one again. So I found that you really have to tweak it a lot. I actually have too much. It's kind of bogged. There is a couple of things that I'd like to share before we continue. Let's see where we can find that. In the windows itself, if you pull in the left-hand corner, you have different options. And one of them is if you have anaglyph glasses or if you have a 3D monitor, you can choose to look at it in anaglyph. So if you've got anaglyph glasses, there you go. You can watch it. Hey, in fact, I do. Here we go. Hang on. Yeah. Yeah.
How does it look?
You want to take a look at? Oh, just kidding. Yeah, it actually looks pretty good. So if you have some glasses and you don't have to spend much for them, you can get a three-dimensional. They make some polarized, and I have one that either uses vertical or horizontal, and you then use polarized glasses like you have in the movie. And another feature that somebody's written, I have to see if they've created a new plugin, but if you have the Oculus Rift, you can get a plugin so you can look through Oculus Rift glasses. So it is kind of cool. Let me go ahead and turn it off again. Yeah, for some reason, there we go. Seems a little sluggish, and I don't know why. But you can identify the background color. And sometimes I like to do that. Yeah, this is really sluggish right now, and I don't know why.
Yeah, mine's a little sluggish too, actually. Maybe is it the nightly builds or?
No, I was just using it for about an hour before this and wasn't having any issue. But let me find, there is a setting that you can turn on. I thought it was here. Oh, actually, it's down here. You can identify the detail mode of it. So like here, well, we'll get to it. I don't want to take any more time. There is a mode that allows you to use what they call adaptive or high quality. And what that allows you to do is essentially when you're rotating or moving the object, it goes to a lower quality. And then, yeah, we're on adaptive. Or you can do maximum quality. So if you notice, when I rotate it, it looks pixelated. But when I let go of it, notice the model sharpens up a little bit. Actually, it didn't really sharpen up. That's what I get for messing with things in the middle of the show. Let's see. And as mentioned, make sure if you, oh, that's another, there we go. Notice I'm on VTK CPU raycasting. So this is the technique. Oh, look at that. So let's switch this to GPU.
I'll tell you, Mike, I'm having a good time. I'm using the Surface Pro 3 right now. And so
It probably works really well, huh?
Oh, it feels so good. I don't know if you see my hands going across the screen, but I'm just kind of maneuvering all the different slices with my fingers and using bits of that and the mouse, and it feels great as I'm just like manipulating it.
Actually, I've got a touch screen on this particular laptop too, and I can do it. All right, well, let me, let's see what, okay, so we're on GPU now, so maybe that'll help. We're on adaptive. Okay, so we should be good. The thing about laptops is they still have the built-in Intel graphics processor, but they also, in my case, have a discrete NVIDIA. But sometimes when you launch the application, if you don't choose the NVIDIA, you're actually using the Intel. So that may be part of the issue as well. Okay, so let's get back into, if you notice, we still have kind of a ghostly-like quality to this. So let's go back to our volume properties. See if we can kind of solidify that a little bit. There we go. Now it's still going to look a little rough. I may have to reboot it, but or actually just redo the program. But I want to turn on something called ROI, and this is what I think is the power behind these applications. And I'll go ahead and display it now. Notice I have these little beads or pins on my different views. And notice what I can do by moving them. Notice how I'm slicing away the front. Well, this allows me to peer inside. So if you remember, this particular demo had a tumor, if you can see it in the right-hand side. So now, as you can see, it's very obvious. And we can actually work with this a little bit more. You know, did you know what I did wrong there, Jevin?
What
Remember, this was an MRI.
you use
What was I
the
selecting?
CT.
Exactly.
Yeah.
So if you notice, the MRI has a much larger opacity map than the CT version.
Mhm.
Okay, so I mean, I can tweak it, but the idea is you should be able to see the tumor in there fairly well. And we can keep tweaking these, and we can add them like I did before. So if we wanted to, we can bring this down. And what you're doing is modifying the regions that are going to be used to create the volume render, which is the grayscale information you see on the right-hand side here. In fact, if we wanted to, if we find that that works out for us, there, we can go to the grayscale and modify it here. And then we want to get further in on one side. So we can literally do virtual surgery here. And so what I was doing earlier, and I think I can get to the same point, is if you do enough ROI segmentation, I should be able to isolate just the tumor itself. Voila. So obviously we can examine. There are some measurement tools in there. But you know, coming from an engineer background and designing things in CAD, sometimes two-dimensional surfaces work better for measurement processes than trying to measure in 3D space. But that is one of the strengths in some of these newer applications. So there's a good example of using the volume render. It's great for creating images. So if you have presentations, you can create a very realistic look, and I use that extensively throughout the last year. Jevin, do you have any questions on this? Anything that it's pretty straightforward once you know where to go and you go through it. But so essentially, I'll summarize. You select whatever volume you're working with, and you can create several. In fact, you can create several volumes with the same set of DICOM views. So that is one of the strengths. So you select the one that you're using. As I mentioned, we only have one here. Then you select your inputs and your region of interest, and you can have several region of interest. Here we're just using one set, but you could actually use more than one and select those differently. Then you select the type of display. So depending on if it's an MRI, CT, or even an ultrasonic, you can identify the regions that are required in order to properly show the graphics or the rendering, what do you want to call it, spectrum of color. And if you notice, some of them use, let's go back to this, so I'll turn this off. Notice that when we did the MRI default, it never does what I tell it to do when I want it to do it. There we go. Yeah, sometimes you have to click on something else and come back to it. But there you go, and then we can obviously go back and modify it to have, but this is kind of a false coloring. And if you notice, each of them provide different coloring. I'm assuming there's some reasons for that, Jevin. In order to do that, maybe you can enlighten me.
Oh, you're saying for the why would want to use the different coloring?
Different coloring. In fact, some of these are standardized, and I've seen them in other packages. Like some of these CTs use false coloring of certain colors. I'm assuming from a radiology perspective, there's a reason for that.
Yeah, well, I mean, it just looks like, if you can, using, let's say, I see there's like a CT angio here, what you're interested in is not just the soft tissue here, but you're interested in the vessels as well. So I could see why when printing, you'd want to make maybe the vessels have a differentiation in color to the parenchyma around it.
In fact, I'll click on this one here, and obviously I don't have enough. Let me turn off the ROI. So like you said, in this case, it may make the arterial structure more prominent. And I've noticed that too in playing with it. Okay, well, as mentioned, this is great for creating images that you can rotate and move, but we're still locked into the computer itself. We haven't taken it to the next step. And I think this is the more difficult step, because right now we can render the grayscale information and fine tune it. And again, let me switch back to viewing this. Another thing too, you can move the actual ROI on the two-dimensional three views as well. So if you notice, I can actually go up here to highlight. So you don't have to do it not only on the three-dimensional screen. So let's say I want to take this a little further. I want to print this. So how do I go about doing that? Well, first thing you have to do, remember we brought up volumes before. We have to make sure that our volume is actually what we want it to be. So here we go. And one of the things that we can do, like before, we can pick different defaults. But since we don't have any MRI choices here, we'll just go ahead and stick with what we have now. And then we can, as mentioned, adjust our thresholds here. And what this does is it kind of separates what grayscales we don't want. And if you notice, as I move these in, you look at the images, notice how we're losing some of that grayscale information.
Mm-hmm.
So eventually, as we get closer and closer, we literally, if you notice on the right-hand side here, only illuminate one region. And then we can, if we do this correctly, select in the middle without touching the two sides, move it back and forth. So we're moving that threshold boundary to wherever we want to. So I'm not going to change the name, but we could continue to use this particular threshold and call it a certain volume. Remember how we could choose volumes. So we could modify this and say, all right, I want this to be a volume of a particular region. And we can go through this and use this to determine different information that we choose for some of the other applications. But I'm going to leave it like this. And then I'm going to go over here and choose something called surface models. And there are routines that you can work through. And the one that I choose is the Grayscale Model Maker. And this is a very quick way to convert one of the volumes that you've created into a three-dimensional model. And what it does is it takes those threshold levels, and I'm going to turn this to 1%. If you leave it at 100, nothing happens. So I don't know why they chose that as the default. 50% kind of determines the regions that we were talking about. So it may or may not be what you want. If you go to the 1%, anything above it is not used, so it's only below it. And the thing about 3D tangible models is you either have material or you don't have material. There's no such thing as a grayscale material. You're either printing it or you're not. So you have to think ahead of time, what do you want to print? Think of it as a shell. And anything that looks grayscale won't work. It essentially has to be there or it doesn't have to be there. So what I found that I've done and others have done is that they create multiple models, let's say of different grayscale levels, especially if they're different regions, and then they assemble them later on. So what I'm going to do here is pretty much leave everything except the decimate. The Decimate allows you to get less triangles. One of the things that I found is some of these are pretty dense, and they create very large files. And when you try to manipulate them in other applications, they could slow them down. In some cases, some of my earlier skulls actually broke some of my other 3D mesh tools. So I found that the decimation really works well in order to reduce that before sending it somewhere else. But in this case, this computer I think is powerful enough to apply it. So what I'll do now is go down to apply, but make sure I'm selecting everything correctly. Yeah, notice where it says output geometry, it says annotation ROI. That is one of the ROI labels. That's not what you want to use. So what I would do is go over and create a new model as, so you can put your own name. And you can name it whatever you want. And then go ahead and apply it. If you don't change that, it doesn't create a model because it's not using a name that you chose. So I'm going to go through this. That's kind of, oh, look at our model. It's there somewhere.
You made a box.
Made a box. But why is that?
Well, does that have anything to do with the threshold back at 99?
Well, let's see what happens. We can play with that. Well, it's taking longer. There you go. So yes, I put it at 99. Like I said, 100 didn't seem to do anything. 1%, as you saw, actually worked on the inverse side and gave me a volume of empty space, which showed it as a positive space. So there you're seeing a surface. So this would be a quick way if you wanted to CT scan yourself and create your own model of your head. But notice when I open it, there's a lot of stuff inside here. But if you look further in here, and we're going to do another little trick here shortly, it's empty. And because what it's doing is it's modeling all this information off to the right-hand side. And see how there's little speckles in there? So all those little white speckles are being produced as voxels. So if you go to the bottom, see all this little white area here? That's what this is. So you really have to work hard at ensuring you have a clean model. So what I've done is once I have this model, there's another tool. And let's see if I can go in there and actually work with it. And this is what I worked with earlier. And this really helps you, one, when you actually do skulls out of CT, of differentiating it. And it's in the same area as the other surface tool, but it's called Surface Toolbox. And it is kind of like, actually, this is new. This is something I was asking for before. This is actually a toolbox to do cleanups of models internally, so you don't have to go outside of it. And one of the things that I had issues with that you can't see here, even though this is a three-dimensional model, is that, let's go back to our models. If you're familiar with 3D, there's actually two sides of a surface. And normally you show either the front or the rear. But if you're looking at it from the rear and you don't have the normals turned on, you don't see it. It's invisible. So this gives you the ability, and what was happening to me when I was creating a 3D model to look at is, yeah, here we go. I'll turn that off. I wasn't able to see, but since there. So I've just turned off the front. And notice how I've got this region, and the reason that you're still seeing this. What else do I still have on, Javin?
Let's see.
Well, I'll save you a little time. I still have the volume render on.
Uh,
So notice when I reversed, let's go back to the model. When I reversed the culling process, it actually removed the front surface. So there's actually 2 layers there. So as you can see, by creating a 3D model, there's a little bit more than just pushing one button. You have to fine tune it, make sure your threshold level is set so that it matches your volume correctly, so that you notice we've got some spurious voxels here. And a voxel is a 3-dimensional pixel and surfaces. So we want to make sure, and if you look closer in here, you could probably see that information. You want to make sure you get rid of that. Now, what I normally do is sometimes I don't do anything and just wait and bring it into a 3D mesh model program, and I clean it up using other techniques.
Now, Mike, do you want the region of interest to be as big as you have it?
Ah, good point. No, and the reason why, even though the region of interest that I show here on the model is smaller, that is not the volume region of interest. That's the volume render region of interest.
Okay.
So what we need to do, and thank you for saying that, we need to go up to our volume. Let's see where we can do that. I've lost my memory. But yes, that is an important question, and there is a tool, and I can't remember, I had just done it earlier, where you can modify the model or the volume so that it only has a certain portion to it. And then in looking through here, I'll bring up another tool that I think is useful. Well, since we're still in remember I mentioned there was something called, here, what does it say? So remember I was talking about a tool that allows you to clean this up. There's an editor tool. And if you go over here, let's see if you can expand this a little bit. You can go through here and actually clean up all those little areas that you don't want by these tools over here in the left-hand column. And so like you can erase things, you can paint. So you can create regions in there. And these can all be used to add or subtract from the model that you generate. So there's plenty of tools. I'm not going to go through them all, but there's an extensive number of them. And I worked with another program called Imbecilius, and I find that working with these tools allow you to clean up the model a lot faster and get better results when you finally create whatever the object is. Well, it escapes me. But the answer to your question is, and I will bring it up later, Javin, is yes, there is the ability to create an ROI specifically for the volume. And what it will do, if I find the right tool, which obviously I can't, is it will allow you to so this is, at least to me, this is one of the problems with this application, is that there's so many selections that unless you use them on a day-to-day basis. It's easy to forget some of them. Oh, well, I won't take any more of your time and others who may be listening. I will put it in the show notes. But yes, that is a good question, and obviously I can't seem to find it right now.
Okay.
And actually, when we go through yours, I think that might be clearer. I may be able, it may come back to me at that point. All right, well, let me get to the next step. Get this out of there. And that is, well, what do we do with it after this? Well, the problem is this model is actually saved as a VTK, which is what you see here. What we want to do is save it as an STL. Right. And then you can choose wherever you want to save it. And I created a location called tutorial, and then I'll just choose that. The rest of them, I'll just go ahead and let it save it where it was at. Okay, so I should be able to now bring up and there it is. So I'm going to launch it in my favorite program, and they have a free version and a low-cost personal version for $200, which is what we'll be using here. And we're going to load that STL. Now, one of the things it comes up with is that it's not a good model for printing. So I'm going to go ahead and let it add it. But there's our model, but there's a lot of shells in it. And what are shells? Those are individual pieces that aren't connected to anything. Like the whole surface here should be one shell. So one of the things that I can do in this application is hit this little red cross here. And then go to shells, and it should show me all 1,000 shells. And because there are so many, so what I'll do is I'll just remove. It will take a little while, but I'll just hit delete, and it should come up with a menu item saying, hey, do you want to delete all these? And it will remove all the shells except the main one. Now, again, a lot of this, if we had taken more time, we could clean up like I was showing you within the application itself. But I use a combination of these two, one to make a solid model that I can print. So when we get done with this, I still don't think we'll be ready, but there are a couple of other tools that we'll be able to use to create a print-ready model. So I think it's kind of a 1-2. You can use the 3D slicer to come up with the model and then bring it in the NetFab or even Mesh Mixer, which is a free program from Autodesk, to clean up the print object even better, and more importantly, determine if it is print-worthy. And once we do that, we could reduce the size of it. So if you don't want to do a full scale, you don't have to. Most printers will do full scale as well. But once this finishes, so it gives me time to. So I'll tell you what, I'll let this work in the background. And I'll jump back to this. Hopefully it won't eat up too much processing time, and I can still.
And Mike, let me just ask you, in the
Sure.
model that you're cleaning up right now, just because I assume that, when people make these STLs, they may not just want to print them, but they'll also want to, let's say, post them online to share. My question is can then you resave the STL from that program cleaned up and then post that one, let's say, to.
Oh, yes. In
Okay.
fact, and in fact, once it's done cleaning up the shells, I can show you how that works.
Great.
So yes, you can do that. And either this application or Mesh Mixer. Now keep in mind, when you're working with these STLs, make sure you can decimate them to the point. And what decimate does is it reduces the number of faces. But if you reduce too many faces, you lose the distinction of the model itself. So you need to do a fine balance there, and you can look and see if the default, I turned it off on this one. But what you'll find if you have too many faces, that really burdens the processor and you spend a lot of time, but you may want that detail. Sometimes you don't need it, so you'll have to play with it. For instance, the skull here, can't remember, it has like 3 million faces, so it's pretty hefty, but it also gives me a nice smooth curve. So that's the possibilities. And what I have found with 3D printing, unlike in the visual world, where you can use software algorithms to create this curve or smoothing, you don't have that flexibility with the printers. So you really have to create the raw faces in order to provide the smoothing. And what do I mean by that? Imagine, let's say, a sphere, and a sphere is actually an infinite number of points in order to keep it spherical. But if you reduce those points, eventually you start to see faces on it, like a golf ball. So you need to create a balance of how many faces do you need in order to create a good shape. And I find that a model like this really does well with anywhere between 1 million to 3 million. So if you are on the fence about getting a faster machine and want to do this, I would suggest getting it. Now, this is probably a good example for the Surface 3, which only has the Intel GPU that's built into the processor. And if I remember, you have the i5 or the i7, Javin?
The i5.
Okay, so the i5 I think has a 4400, if I remember correctly. So it's not the top end. So you're going to have some limitations on using the GPU functionality. But with a lot of these mesh modifying or editors, they don't use the GPU, so a better processor is probably in the works. And the i5 is a decent processor. So I have to give kudos to Microsoft in developing, in my opinion, a pretty good Surface tablet that has some horsepower. And let's see what the new one comes out. But in fact, they came out with not the. You have a Surface Pro, right? Yes, because it's got the iPad.
Yeah.
I've heard good things about the new Surface 3, which is a lower cost unit they're making for the educational market. Let's see, maybe that. Yeah. It may not work. So as mentioned, sometimes when you're doing way too many things, the programs don't respond the way you want to. So use a balance. Make sure you do as much as you can in 3D Slicer before bringing it over like I did, thinking I would save some time. In reality, I probably didn't. Okay, well, if that doesn't take up too much processing time, I will move into our next model. Now, this was based off of their test model, and one of the things that I'll hit cancel. Go back to the models. So the other thing is, that if you notice, there's that little eyelid that we had earlier. That's kind of nice because you can go through there and turn off anything that you don't want to show. So we can turn off the model. We can go back to the volume render, and we can turn that back on. We can go through now and actually turn off the synchronize with volume model, choose one of our MRIs again, and now get a more realistic view. We can slide this over so we have more space to work with, and go back to our ROIs here. And show a better view of that tumor. And then if we wanted to, we can go here. We're almost there. It's interesting what's actually showing up when we do this. Well, again, fine tuning, but notice how we're actually isolating the tumor itself. But notice more of the vascular system is showing up in this once I start clarifying. So what would that tell you? I mean, I don't know where they got this particular MRI sample from, but as a radiologist.
Yeah, well, I'm trying to look at what you're kind of playing around with, and it looks like it's the opacity, right? It's opacity mapping.
That's a scalar opacity mapping. That's already been keyed to a particular color.
Mm-hmm. Yeah, so I wonder if it's kind of highlighting the properties of the tumor and everything you're seeing there. If you're kind of restricting, again, this is what I'm guessing in terms of what this function you're doing. If it's kind of restricting it to a certain characteristic that it's looking for, then it's interesting. It looks like maybe that's what it's highlighting there is all those structures that you're seeing, or if that same kind of, an MRI, it's what we had talked about before in terms of what the magnet's picking up. So it's interesting.
Yeah, and as we talked earlier, there's obviously different settings that you can do with an MRI. In my discussion with Dr. Scott Cleos, you have T1, you have T2, which is also are all part of the fall or the excitation of the
absolutely, of the magnet
the
itself.
atoms themselves, and those levels. And the problem with DICOMs is they only give you grayscale information. They don't give you the spin. They don't actually get the acceleration. So you don't see any of that information. But whoever created up this particular MRI default also used some color cueing, and that's what I'm isolating. What I notice when I isolate I'm assuming the gray matter, I am left with a lot of just vascular. As a doctor, what does a tumor normally consist of? What makes it different?
That's kind of the medical answer, I guess, would be depends, because it's kind of what I was thinking. You can have sometimes tumors that are of one consistency. It could be similar to the parenchyma itself. You could have something like a teratoma that's pretty much every density and every type of tissue you can think of in one tumor. So this tumor looks much more homogeneous, which makes it a lot easier on this. But, let's say you had something that had a few different densities in it, maybe with like a cystic component. That would be interesting to see how it worked with this. It's I think it'd be a little bit more difficult because, as you're playing around with these, basically, let's say we're on CT, if you're playing around with the densities, that'll get a little difficult if, let's say, you drop out the bone density, but the mass itself has a bony component to it, as like teratomas can have, or even calcification, which would have a density similar to the bone that you drop out. So yeah, it would be interesting. I think it'd be a little bit more tweaking you'd have to do if there was more of a heterogeneous component to the tumor itself.
Well, Javin, I kind of led you into that. As you know, in my case, or my wife's case, that's what she had, even though she hates using the term bony meningioma. That's what it existed. There was a lot of calcification and bony materials. So it showed up as a dark space on an MRI, which was our initial test, but lit up on the CT. So essentially, I'm glad that we have different technologies that allow us to highlight different materials that we're made of. So yes, and in this case, I went through and I didn't remember anything that you said, that this is more tissue-based versus calcified or calcium-based, which doesn't show up as well. But I just out of my own curiosity, in modifying this, the brain tissue I'm able to cause to disappear because I'm modifying the thresholds because it's at a different grayscale level or color level, and then all that's showing up now is the vascular. So I'm wondering, and actually I'm kind of answering this question myself. Yes, it is kind of obvious that because you probably have more of a, what do you want to call it, not necessarily a liquid, but water molecular in the vessels and so forth, that it might be more pronounced.
Yeah, well, and Mike, just something else to add that I think you pretty much said is the fact that tumors themselves are mostly vascular tissue. And so maybe also what this is highlighting, what you're doing right now, is just the high vascularity of this tumor, as well as most tumors are. So, I know we're working in the brain right now, but there's a lot around the body that could be played around with about the vasculature of the tumors, such as in liver tumors.
And they're actually obviously doing that. Okay, so enough of this one. Let's jump back to NetFab, see if it behaved, but no, it's still dead. That was a mistake. So I'm going to go ahead and kill it. I don't think that's a word you want to use in what we're doing right now. Huh? We want to save. We want to save our program. Okay, so now we want to go ahead and clear the slate. So we'll close the entire scene. Should hopefully take us back to a clean slate. Now, why did I want to do that? Because what happens if you leave remnants of previous scans and modifications, they show up, and then if you don't turn things on and off properly, you're wondering why am I still seeing this? And or at least that's what happened to me early on, being a novice. So I learned to literally clear the slate. So I'm going to go to the DICOM setting. Now, as mentioned, I loaded this earlier, and I'm going to load the DOA. And as mentioned, I'm going to load just the 1 millimeter, and I'm going to load it. And it was that quick. So notice, as I mentioned, with the 1 millimeter, and again, I don't know how much energy they used, but notice it's like a light bulb. It just kind of highlights, and that's the external tissue. So we're not even just looking at bone. I thought that was a little peculiar. And notice if I make adjustments here, I still can't. I just have a white blob. Now I've been able to tweak it more, but I did find that was a little interesting that they use so much radiation that I'm assuming radiation or detection level that I don't, in other CTs that I've worked with, by just adjusting this, I'm able to pretty much iron or just isolate the bone, and that's not what I can do here.
Mm. Well, again, the 1 millimeter is just talking about kind of the thickness difference between each CT slice. So, when usual slices, if you're in the chest or something, can be 2 millimeters, 3 millimeters. I picked the 1 millimeter specifically just because I wanted to bring something with some good detail to it. So,
and actually, we'll go ahead and write into a volume, and yes, you'll see the big difference in, I don't know, I'm assuming from my understanding that it, at least on, not the latest generation, but those that can do 1 millimeter in the last, 2 or 3 years, it still takes longer than a 3 millimeter because you're taking more slices, if I understand correctly. And there's still time that's required in order to process it. From what I've been told by Dr. Cleos, what they're doing now in order to, one, minimize the radiation is to use more receptors. Let's just say cameras on the other end. So we now have multiple points and using algorithms to combine that to give you the same capability. But by doing that, they also have the ability to process more quickly. So what would take minutes now takes seconds. In fact, GE just came out a few months ago, actually I think it's about 6 months, with something that's almost near real time. So you can literally see the heart pump and things like that because it's able to cycle through the slice operation so quickly. And again, I think it's because of these multiple receptors, not necessarily, because I guess you've got a certain finite period of time that you can fire the electron beam. So they must be doing other tricks on the other end, which is very cool. Because
and the post-processing is just getting better and better of all of these systems.
And I mentioned to Dr. Cleos that one of the things that I read is they're actually using NVIDIA GPUs in a render farm in order to do this. So it's funny, the same thing that's generating the games that you're doing shoot 'em ups with is also the same thing providing the GPU power for some of this fancy 3D rendering for medical imaging. Okay, so let's click on volume image. Again, do the same thing. We select it, which is the 1 millimeter planning. Before I turn, let's see, I'll go ahead and turn it on. And there you go. So if you remember the one we just, all right, come on. There we go. If you remember the one we just looked at, look at the difference in the 1 millimeter, and I'm assuming that was probably a less resolution. It's smoother, more detail. we look at the inside, you can see that there's some interesting stuff going on there. So right off the bat, much better detail. So now I'm going to go through and actually choose the MRI default, which I guess it was already on. We'll turn on region of interest, make sure we're on GPU so that it doesn't bog us down. But notice the, it's kind of funny, it didn't actually take it. I wonder why. All right, here we go. Huh. Remember how we were talked about getting bone? Well, there we go. We got bone immediately with
Very
the
nice.
MRI angio. But again, notice the actual scalar opacity mapping. It is essentially literally just a threshold, either on or off, which wasn't the case here. So there we go. So notice the difference. For whatever reason, either it's my system, I have to switch to something else and then click back on it for it to modify the opacity mapping. So notice how we're actually looking at a more gradual curve instead of just a threshold. And with that, we actually can see some of the bone and some of the tissue.
That looks nice.
Yeah, isn't it? I mean, it's very realistic. And one of the things, here we go. One of the things that I identified before, it's almost photorealistic. So you can get high quality anatomical images that you can use for reference in discussions, meetings, and so forth very quickly using this application. And again, if you have access to some of the higher, pricier versions of this, you can do the same thing. And some of them have algorithms and one-button processes, but they're more expensive. You pay for that capability. But if you are a programmer and you know Python, you could do the same thing here. You could create your own little algorithms and buttons of something that you want to work with on a daily basis. So let's go over here and kind of tweak these a little bit. Let's see what we can do. Notice how if I pull that down, I can almost get rid of the background there. So let's play with our region of interest. So let's look at this from the side. Again, remember, you can adjust it here or there. We have almost nothing in this. Actually, I shouldn't say that, it's just ghosted. So we could probably, if we brought this back up,
Well, we also have to adjust the window, the grayscale on the to the right over there.
well, actually right now it doesn't use that.
Oh, it's not using that. Okay.
No. If I go over to this and synchronize, here we go. There we go.
Ah.
But if you remember, you don't have as much control over that here. You then have to select the actual volume itself. And then select the volume. And then go through here and select the proper. And again, these are all for, well, we are using CT. So let's do the brain one. So notice immediately we have the proper thresholds. We get a much better view. Everything is peachier. And then if we wanted to, now we can modify and get a much better control over it. So you mentioned that this particular scan has a tumor, correct?
Yes. So I think the best way to get to that.
So should I change my view and just to let you know, we could go back to our conventional, which gives us, actually this is way too. All right, we'll just do this.
So yeah, if you want to find it, I'd say the best way to do it is to go under the axial view, in the red box there.
Okay.
And what you're going to want to do is scroll down a little bit and adjust the window to make it a little bit darker. Yeah, like that. And then scroll down a little bit.
Okay, left to right.
Keep going, keep going. And if you can see it, just because I'm doing this watching your screen, yeah, kind of exactly where your pointer is, you'll see there's in the left thalamus. No, so it's not that white actually. Again, I'm looking through this onto your thing, just because mine's still uploading here.
Let me see if we can go to just. That's not the mode I wanted. Oh well. Okay, so I'll just stick with this one.
All right, so you want to keep scrolling down. Scrolling down, and actually, it's funny on my screen. Your head's taken up. That's okay. Yeah. So you got it kind of right there, and if we're going to adjust the grayscale a little bit, go up a little bit. You can see it, and again, it's actually, I don't know if you meant to do this, but where you have that purple dot there is going to be pretty much where it's going to come up. All right, that's perfect. All right, so come up a little bit, a little more superior. Keep coming up. Okay, and as you can see, the definition on this is not as good as the monitor I was using at work. Yeah, that's exactly. You change it there. You can see kind of where that is. You're going to see mass. It looks a bit heterogeneous. And I'll have a better thing once this is uploaded. I'm at 50% right now. So a little bit essentially posterior to that purple dot you have. So if you move the purple dot a little bit down, oh, okay, that's fine. So exactly where your mouse was, if you go back up and move, and basically your mouse,
which
sorry,
quadrant do you want me
in the red box, and I would say right there, kind of where you have your mouse there, a little bit up from that, you're going to see that is going to be where you're going to have a thalamic mass. And it's hard to see it from my screen onto yours.
What I'm going to do is I'm going to take my ROI, and create a box around it. Is that about it?
Yeah, yeah. In fact, if you move the yellow dot a little bit to the right, a little bit more, you're going to be essentially there. Exactly. And we can, it's going to be right in that area, and we'll examine it further on a few of these other cuts.
Okay.
Yeah, you can actually, you can see it actually kind of nicely on the 3D right there, if you see.
And then let me bring this down. Okay.
If you come down a little bit, you actually had it look like visualized. See that opacity? See it right there in that plane. Yeah, I think.
Okay, so let me change my screen again. Let's go to the wide screen. Let's zoom in on it. So you think that's it?
Yeah, I think that's what it's showing right there.
So again, this is a CT scan. So if it's illuminating it, that means it's, well, has this already been diagnosed? Do you know exactly?
Yeah, well, I mean,
the tumor?
illuminating it, enhancing has to do with whether there was contrast given. And usually masses in the brain do have essentially enhancement with contrast. And I do know the spoiler alert on this is that this will be a thalamic mass.
Okay.
I don't know what type of tumor it turned out to be, because I don't know if they ever biopsied it, but it will be a thalamic mass.
Okay. So like I mentioned, and I can't get the little dots here, we could expand this a little bit more. And then we could actually look at it from the bottom if we wanted to. All right, so let's see what happens if I reduce this so that all we have is that. And then we should be able to go back into our volume render and modify. Oh, okay, let's do this. Turn that off. We're almost there. What I want to do is, getting there, I want to cause the black to disappear. There. There we go. Close.
I'll tell you,
So
we're picking up a part of the bone, but that's fine. I'll load mine up now.
well, I'm assuming the smooth area here. But obviously, if one, if I were trained to do this, and two, if I had spent more time on it, we could do obviously a lot more. Okay, so we have this, but this is still not a tangible model. So we want to get there. And as I mentioned, there is a way, even though I don't remember right now, you can convert the ROIs that you have here to the volume so that all you're segmented to is to the volume itself. And I had done it right before the show, but since I have a failing memory, I don't remember how to get it back. And let's see. No, that's not what I want. Oh, well, I won't waste any. No, I've got something there I don't want. No. All right, so let's say we want to do the same thing, and we'll very quickly, you would go through there, and the first thing you need to do is make sure your volume is set up correctly. So we'll center it. No, that was not good. It took me out of where I wanted to be. All that work for nothing.
It's okay.
Oh, well, but I wanted to print this out, so let's go back and there, move it all into the plane. All right, so you now can go back. Let's choose one of these others here. There we go. And now we want to create a 3D model of it. So we're going to, there's a couple of ways to do this. They have a algorithm called watershedding. And what that allows you to do, if you just want the brain and you don't want the bone, you apply that tool. And let's see if we have, I don't know if I loaded it up here. Yeah, you'll have to download it, but essentially there's a tool that you can download, and there's a couple of them. And what it will do is it will segment out just the brain, remove the skull, and then you can obviously clean up that to create a model. But I didn't download it, but it is a free plugin to work with. So what I'll do now is I will go back to the grayscale modeler, select the model, create a new, and so what do we say worked best? 99?
99, I think.
Okay, we'll leave the decimation where it's at, and then hit apply. The other thing too is that if you apply decimation, that's another algorithm and process, so it takes longer. So if you reduce that time, it can get you a model quicker. It just has more faces than otherwise, but this one doesn't seem to take very long. Okay, so we have something here. There you go. Wow. So, as you can see, we actually have a skull. Now notice when we look in here, let me close this window here. See how there's still a lot of stuff in here? So what you could do is, remember the editor tool, you can go through, and if you see where my cursor is, you can actually clean up. Now, there's a couple ways of doing this, and obviously with 1mm slices, I don't remember how many are in here, but let's say there's like 300. You can either clean them up individually, or you can assign a region and just say go through all of them, which is a positive and a negative, because if you go through all of them, you actually go through the outer surfaces too, but you can assign how many you want to go through there. So it automatically will go through and clean up a region interior in the internal portion without touching the outside. Or, as we're going to do now, we're going to take this model and we're going to save it. It's not cooperating with me. There we go. It's hiding. So again, remember what I mentioned, it provides a VTK, and we want to turn that into an STL. We'll change this to our tutorial. We'll choose it. And if we wanted to, we can change this name to skull. And then hit save. And we can actually uncheck everything except the skull. So if you don't want to save anything else, you can do so. And now we should have a skull. Yay. Okay, make sure, okay, so it should be this one. So like before, we'll go ahead and open it in NetFab. And again, it has a ton of shells. But there you go. So one of the things we're going to do right now is maybe not take off so many at one time. Let's do them a little bit slower so we can get through it. that. Go to the shells. And let's get rid of some of maybe the larger ones. So keep in mind the shells are floating pieces that aren't part of the main model. So yes, this seems to be a better way to go. But keep in mind, maybe some of those shells you do need, like maybe it's part of the jaw or something. And then you just want to use other tools to get rid of it. So don't just blanket remove all your shells. You may have to merge some. So one of the reasons that it looks so dense is that, and I don't know if I can turn it off here, but it does look like I'm able to remove a lot of these much quicker now. So I will. Do you remember how many shells were on the other one, Javin?
Oof, no, I don't remember. But,
I think it was in the thousands. So
yeah.
that probably didn't help either. See, I probably pushed it again and wasn't patient. Let's cross fingers that it does come back properly. Yay. Well, still have a few more. Okay. So we're back to just one model again. So let's apply repair and remove the old one, come up with a new one. But we still have some errors with the model. And if we look in here, we still have, well, part of it is, can you see the little red area here on the model?
Mm-hmm.
That's identifying that the faces are, remember we talked about how they're projected in the wrong, they may actually be hollow. But to save time, we're just going to go ahead and keep going. All right, come on. So I would go, you ask if you can save, you can. You can go up to Part, Export as STL, and there are other types that you can leave the name or you can change it here if you want. It may come back with some errors, which it will, because there's some manifold edges, which is what I showed you, that needed to be cleared up, which I didn't do. But we can do it here before you export it. So now we can export it. And so I'm going to get the SD card from the printer and then show you how to load it onto the SD card and then how to actually load it on the printer. So give me 10 seconds. Okay, I'm back. So I don't necessarily have to do it this way. I'm doing it because I don't have this one hooked up with a USB, but you could actually use Cura. And actually that is something we have to do now. So now that I have saved the file, do I remember where I saved it? Probably not. Okay, so let's go down to tutorial and do the same thing. Export. We'll minimize this. minimize that. And then we'll bring up Cura, which I loaded earlier. There's your bed. So now we need to import that same file. So we click on Open, go to Tutorial, and we look for skull. Let's see, is that the right one?
Yeah, I believe. Oh.
There we go. My clock is wrong. Oh, it's because I'm still in Spain. All right, so there we go. We have a skull. So it looks like it actually could print on that little bed. So what we need to do now is calculating how long it will take. But you can choose the quality of the print, and down here is your gauge. Now keep in mind, again, the number of faces you have, the more faces that you have, the longer it's going to take for this whole process. But the advantage is you get much better quality. If you notice, you actually have, what's the term for those crevices in the top of the skull there?
Sutures.
Oh, you mean this area right here, or this was?
Yeah, those are our suture lines.
So this person has already had a craniotomy.
No. I mean, just these are anatomic things. You know, if you can
so
see
it's
the frontal bone, the temporal bone, how they come together.
Huh? You know, it's interesting. Siobhan hers are not that distinct. So why would that be?
Well, I can't really give too much information on this patient, but let's see. Now, you know, maybe it just has to do with the 1 millimeter thick CTs. Maybe that just
well, like I mentioned, the scan
itself.
This one here is 1 millimeter as well.
Yeah.
She didn't have those lines, so.
Yeah. But I assure you, you have those lines and I have those lines. Yeah, and she does too.
Yeah. Well, and again, I've seen that on other skulls, but this one seems a little more apparent than others. Okay, so the term is called suture?
Suture lines, yes.
Okay. Getting an anatomy lesson. It's funny how people learn so much more when they have a medical issue, nowadays at least.
Yeah.
Which was the big reason that we did the TED Talk, and one of the reasons I enjoy giving these presentations is, you know, kind of learn as much as you can about what's going on. Okay. Well, it appears I keep bogging down our system. I'm not. All right, well, let's just pretend that it calculated this. So essentially what it's doing now within the Cura software piece, which is what works in order to create a 3D printable file, is it creates what they call G-code. And this is what tells the 3D printer how to print all the different layers to create an object. And so like I said, to save time, we're actually not going to go through this, but once this is done, I could save that to the SD card that I just popped into the side of the laptop, plug that into the front of the Ultimaker printer, choose it, and then print it. And then it's essentially autonomous. Or you could hook it up with a USB cable and run Cura directly to it, and then it would export it to the Ultimaker. So on that, it won't be this skull, but we'll pretend like it is. So this is a little tiny skull of the one earlier, the larger one that I showed you. And this was printed on a similar type printer. And this took about 3 hours. Full scale was 8 to 12 hours. So yeah, and that was actually just for half of the skull. Obviously, if you needed a larger piece, it would take longer. And that's the sad thing about 3D printing right now, is it still takes a while, but what was your recourse before this? If you find that, I think, Jevin, you're wanting to try a low-cost solution,
Yeah.
there are locations like Shapeways, but I'm also assuming you want to go this route because of HIPAA and privacy concerns, so that way you don't have to provide any information. You can all do it in-house.
Exactly.
I do know that some of the, I don't know where it's at, but I do know that some hospitals, probably medical schools, have spent money on more expensive printers. Can't think of them, like PolyJets and things like that, in order to do this. So I know it's happening, but yes, I'm pretty excited to see how you're going to approach it.
I'll keep you updated as it goes along, and
Yes,
I'll
please.
send some of the prints that we make.
Okay, well, it appears we are updating. It decided that it had enough of me talking today, so I was going to finish up. So on that, let's kind of wrap things up. Hopefully, Javin, that gave you a great overview on how to get from one point to another. I apologize for not being able to show you the volume ROI directly, but trust me, it is there, and it will allow you to clip specific areas just like we did now in order to create the tangible model. But as you can see, it's after you get used to it a little bit and work with it enough, it's a very powerful tool. As mentioned, is low cost, but again, the caveat and note behind 3D Slicer, it is not FDA approved. So if you do require something that's FDA approved, there are some other software selections out there. In fact, we just brought it up on a show, and I can't remember the name of it.
I think Mimic is
Mimic is the big one, but
Yeah.
I think there's a fairly hefty price to that one, if I remember correctly.
Yeah.
When I looked at it. But there's another one out there that's, and I wish I remember the name. We talked about it. He's using it. His, obviously dogs have bones as well, but he used it to help his veterinary print out the knee area for his dog, and they were able to use that. Now the guy's going to go off and do a talk, and he's asked me to, well, he hasn't asked me yet, but to be part of it. So obviously there's a big role in other things besides human in this type of stuff. In fact, I've heard that they've actually used this to create replacements already, and that's going on. So I think there's a lot of opportunity. But again, I don't remember the name of the software. I will put it in the show notes. You can actually get an FDA-approved license of that, and it has some of these utilities in it. It's $99. The sad thing is it's Mac only, so I need to talk to them. What's up with that? But as mentioned, 3D Slicer, Linux, Macintosh, as well as Windows. And as Javin said, it seems to work well with a tablet. It allows you to scroll around, and I have to say I agree because I was using the touch part of my screen here, and it seemed to work as well on my laptop. So if you don't have any more questions, Javin,
Yeah, that's great. Thank you
see
so
if
much.
I got any emails.
It was me just giving you that I had a ghost in.
Actually, there's a couple, but they're not related to this. Well, so it doesn't seem to be no questions. So I don't know how many people. Now we have 4 viewers. So currently we have 4 viewers. So thank you out there for watching. I hope that we answered a lot of questions. If you have others, as mentioned, you're welcome to email me, or you can go out to 3D Slicers. They've got a great forum out there if you have any specific questions. It is, again, a great tool, free. Again, it is not to be used for FDA, but if you're wanting to learn something, some research or so forth, it is a great tool for that. And there are people building plugins for it all the time. So on that note, this is All Things 3D, Mike Balzer, and my special guest today, Dr. Javin, and I've already forgotten, Schaffler?
Yeah, it's close enough.
Yeah. No, tell it correctly. Go ahead.
Javin Chaplin.
Chaplin. So thank you again, Javin, and I
Thank
appreciate
you,
you coming on.
Thank you.
Bye.
Bye.